Right, this is Pure 2, chapter 7.6. So previously, last lesson, we have been working on maximum and minima. Today, we will take a fresh break on a different side of trigonometry. Again, we're looking at proofs, and the next lesson, we'll go dive back into modeling. So in here, since you've learned about how to put the cos x, where was it? The a cos x plus or minus b sin x into r cos theta minus alpha. So some question could be asking you to put that into that format first and ask you to prove some different kind of question. So the reason I put this chapter in 7.6 is because now you would have seen something like 2 cos 4 theta minus pi over 6, that kind of format. But it's actually nothing to do with 7.5 really. So it's more like a proof, another proof using identities, advanced technique on proof. Right, so the structure of proof we did mention before, which is about starting either left hand side, right hand side, and then we manipulate the expression and write in the form of the other side. Okay, and then we can write equal left hand side, right hand side to finish off. We also learned about one advanced technique before, which is if you can't show from left hand side all the way to right hand side, then whatever you finish the left hand side, stop it there. Okay, you don't have to cross out, and then you're gonna start on the right hand side at the same time and see if they can have a same step right in the middle where you can link them together. Right? Right example, prove the identity. Now, a lot of these questions you have done this, you have learned all the trick identities and trick information that you need to know, trick knowledge you need to know. So you can pause the video, have a go at the question first, and then if you struggle with it, then you can hear my explanation. Okay, so you can pause the video now, have a go at this example. Right, so from this question, I'll probably start on the left hand side. Okay, so there's no right or wrong which side you want to start off, as long as you can make it work. Right, so I'm going to start on left hand side, which is quite unpopular, but I'll tell you why. So I'm going to make tan to theta equals to, so I'll rewrite tan to theta. So tan to theta equals to tan theta over 1 minus tan squared theta. So why do I do that? Well, because if I make a tan to theta, I can sort of compare similarities. You can see my step in here. There are 3 terms, 1 on top, and then 2 at the bottom. 1 minus something minus something. So in the same as a question, something minus something. The difference is there is no tan theta in the top. So here's my cue. I'm going to divide top and bottom by tan theta. Everything by tan theta. So if I divide the top by tan theta, that will leave me with 2. Divided 1 by the tan theta is 1 over tan theta. Divided tan squared theta will be tan squared theta over tan theta. So 2 over 1 over tan theta is cot theta. Tan squared over tan is just tan theta equals right hand side. That's proven. And there are more than one way. As long as it works, then it works. Next one. Okay, again, pause the video, have a go at a question. Again, choose one side to start with. When you're ready for the answer, you can press play. Right, in this question, I'm not going to start on the right hand side. Reason being is I see cos A minus B. So just to remind you, cos A minus B equal cos A cos B plus sine A sine B. This is given in the formula booklet. So I'm going to start from right hand side. So right hand side equals to 2 cos 4 theta minus pi over 6 equals 2 times cos A cos B minus sine A sine B. What do we do next? Well, we know cos pi over 6 and sine pi over 6, these are not variables because you can put in a calculator, simplify it. In fact, cos pi over 6 is root 3 over 2. So let me rewrite that times root 3 over 2 minus sine 4 theta times sine pi over 6 is a half. Just one thing, by the way, this root 3 over 2, you're not going to multiply with 4 theta. You're going to multiply as a coefficient of cos 4 theta. So you're not going to multiply, as I said, you're not going to do, this is wrong. You can't do 4 theta times root 3 over 2, that's wrong. Okay, because root 3 over 2 is a coefficient. Same with a half. Sine 4 theta times a half is not the same as sine 2 theta. Because 4 theta times a half is 2 theta. It doesn't work like that. The half is in the front. So let me rewrite that. So it'll be 2 times root 3 over 2, just to make sure you don't form this misconception. The half and root 3 over 2 is the coefficient. We can then multiply 2 into it. So it'll be root 3 cos 4 theta minus sine 4 theta. And that's the same as left-hand side. Proven. Okay. Right. And that, is a relatively short lesson because it's not something you haven't done before. Now, extension, okay, I'll let you pause the video, have a go at the question in A first. When you're ready for the answer, you can press play. Right, so this question, if some of you have a question about this chunk on the right-hand side, hang on, this bit, right? If you're questioning what is this one, this is essentially the domain. This is domain. So you can ignore it for now because we're not doing any calculation about the domain or the range, or we're not solving it. So you can ignore it, okay? What it means in here is A cannot be a certain value. Certain values, because if you have that, you get 0 denominator. It doesn't work. So anyway, this is domain. You can ignore it for now. You can ignore it for this question. So, well, we'll start from one side. Now this time we'll start from the left-hand side, okay? Because sec could be rewritten as 1 over cos, and tan could be written as sine of cos. So yeah, they have a cos denominator. Maybe we can do something with it from that. So from left-hand side, from A, we'll start left-hand side, sec 2a plus tan 2a. So sec 2a is the same as 1 over cos 2a. Tan 2a is sine 2a over cos 2a. Well, I see both fractions of the same denominator. I can put them together. It'll be 1 plus sine 2a over cos 2a. Then I'll be thinking, what should I do on the numerator denominator? Well, numerator, we know sine 2a could be rewritten as 2 sine a cos a. So that's fine. But denominator, cos 2a, we have 3 versions. Do you remember the cos 2a? What are the three variants for cos 2a? Okay, pause video, think about what are the 3 variants. They are cos squared a minus sine squared a, 2 cos squared a minus 1, and 1 minus 2 sine squared a. The question for you is, which one do we choose to make it into? And what's the reason why? How would you justify that? If you have to explain to someone, why do you choose that one? Okay, what would the reason? This one, I will choose the first one. The reason being is, on the right-hand side, we can see from the equation right-hand side, there was cos a with the sine. So there are cos and sine. So I'm going to use, therefore I'm going to use that one. So therefore I'm going to make cos 2a into cos squared a minus sine squared a. Right, but there's nothing else we could do in here. Well, there's one more if you want to argue, which is cos squared a minus sine squared a is same as difference of 2 squared, cos a minus sine a, cos a plus sine a. But if you think of one step ahead, it looks like there's nothing you can do. There is, okay, but it's not obvious. So if it's not an obvious one, I would call that a clever solution. Okay, so I don't want to suggest a clever solution to everyone because that not everyone is as clever as the model answer. Okay, not me is as clever as the model answer. So from here, what do I do in the exam if I were you? I'll probably start on the right hand side. Okay, probably start on the right hand side. I don't know what to do, so I'll start from the right hand side. Now remember, I'm not going to cross out anything from the left hand side because these workings still count. So right hand side, let me write left hand side, cos a plus sine a over cos a minus sine a. So right hand side, yes, you start right hand side. It looks like something logical we will do, but what can we do on the right hand side? Because there's no identities we can use. Cos, we know cos squared plus sine squared, but we don't know cos a plus sine a. There's nothing like that. Yes, but if you think about like a cert form, if I ask you to rationalize this, what would you multiply by? You multiply by 1 minus root 3 top and bottom, wouldn't you? You multiply opposite sign. So we're going to do the same thing from this one. We're going to multiply top and bottom by cos a plus sine a, top and bottom. Now you must multiply the same thing, like on the cert form. You're going to multiply top and bottom by 1 minus root 3. The minus is a minus because it has to be opposite to the plus. Okay, now let's see how does it take us to the next step. So if I do the top, cos a times cos a, cos a plus sine a times cos a plus sine a, that's the same as cos a. Okay, let me write that. Let me write that. So on top, expand double bracket, cos A times cos A, cos squared A, cos A plus sine A to sine A cos A, because cos A sine A times sine A cos A is 2 sine A cos A plus sine squared A. Denominator, cos A minus sine A times cos A plus sine A, that's the difference of 2 squared, cos squared A minus sine squared A. So straight away, realize it's a very similar denominator to the part A, to the previous, to the left-hand side. That means it looks like we're on the right track. And if you compare with left-hand side, the last step of working out we've got, you can see we both have a 2 sine A cos A. What it means is the cos squared A and sine squared A should equals to 1. And we know because the identity of cos squared plus sine squared A is indeed 1. So 1 plus 2 sine A cos A over cos squared A minus sine squared A. And let me explain this in here, cos squared A plus sine squared A equals 1. Okay. And therefore, you can see my left-hand side, even though it's not from the question, my final step is that one of the lines in left-hand side, any lines in left-hand side, if it equals to one of the lines in the right-hand side, then we call it equals left-hand side. And that's proven. So this is what I mentioned in the beginning. You don't have to show from one way all the way to the other. You can start from one side, work it out. Obviously, the algebra has to be correct. And then at one point, if you can't continue, stop there. On the parallel side, start from right-hand side, see if any steps match with the left-hand side. If they do match, perfect. You finish the proof. So that's the answer part A. So what's the clever solution then from here? If I don't want to start on the right-hand side, what should I do? Well, if you don't want to start on the right-hand side, you can first make this 1 into sine squared plus cos squared. Okay, so I'll go on from there. If you're interested, the clever solution, we're going to continue from here. So if you're interested in the clever solution, why is it not coming up? So if you're interested in clever solution, I'll go on from here. So it will be sine squared A. So I'll make the 1 into sine squared plus cos squared. Denominator, I'm going to factorize into cos A minus sine A and cos A plus sine A. And then under the top, x squared plus y squared plus 2xy is the same as x plus y squared. So I can make the top into sine A plus cos A squared over cos A minus sine A, cos A plus sine A. And then you realize these two brackets same, so that will leave you with sine A plus cos A without the square. And that bracket will be gone. And that equals to sine A plus cos A over cos A minus sine A, which equals right-hand side. So that's the clever way. Okay, but that's quite difficult to spot. First, you have to change 1 into sine squared plus cos squared. And also, you have to realize denominator is difference of 2 squares. And also, you have to realize sine squared A plus 2 sine A cos A plus cos squared A is the same as sine A plus cos A squared. Now, it's not impossible that people realize it. People can observe this, people can inspect this, people realize this, recognize this. So there are obviously some clever students can see this. What I'm trying to say is this is not easily spotted by everyone. Okay? And therefore, there are some clever, crazy mathematicians like Isaac Newton, Euler, Fermat. There are a lot of crazy mathematicians. That's because they can see something that normal people like myself can't do. Right. And part B, hence, you can have a go at the question first, pause the video, have a go at the question. When you're ready for answer, you can press play. Right, the word hence. What is the word hence? I've gone through this word a lot of times. What's the trick? The word hence means use previous answer. So you look for similarities and differences. Okay, so look for similarity and differences. Well, similarity, hope that you do realize similarity is sec 2 theta, tan 2 theta is quite same as left-hand side, this one. And from part A, we've proved that sec 2a plus tan 2a is same as the right-hand side. this part. Oops. So you can see it's, oh, it doesn't let me to draw an arrow. It's equal right hand side. So then we can replace this right hand side with the part B, left side of the equation. So sec 2 theta plus tan 2 theta, instead of writing that, we can now use as cos A plus sine A over cos A minus sine A. In fact, the A is just theta. So we'll do that. Okay. So part B. The question was sec 2 theta plus tan 2 theta equals a half. So we use the answer in part A, which will make it into cos theta plus sine theta over cos theta minus sine theta equals a half. What will I do next? I'll cross multiply it. So 2 bracket cos theta plus sine theta equals cos theta minus sine theta. Rearrange it so the cos theta on one side and sine theta on the other. So 2 cos theta, move it. So I'll move this cos to the left hand side. Becomes 2 cos theta minus cos theta is cos theta. 2 sine theta to right hand side becomes negative 3 sine theta. I'll then divide probably cos theta over on the right hand side. So and minus 2 on the left hand side. So 1 over negative third equals sine theta over cos theta. We know that becomes a tan theta. So theta equals arc10 inverse 10 of minus a third. Cast diagram. So inverse 10 of a third, arc10 of a third is this has to be in radians. Is it radians? Yes, it has to be. Oh, yes, radians. From the, you can tell from domain, it has to be radians. So let me put in a calculator. So when I put in a calculator, arc10 of minus a third is negative 0.322. So negative 0.322 is here. For 10 to be positive, negative, the other answer is here. So what are my solutions? Where's the domain? The domain is between 0 and 2 pi. So between 0 and 2 pi, that means I need to go, so the first purple value is going to be pi minus 0.322. So pi minus 0.322, that's my first answer. Second answer is 2 pi minus 0.322. If you struggle to understand what I'm doing in here, think about in degrees term. You would do 180 degree minus that degree to find out the purple answer. And for the other black line, you do 360 minus it. Therefore, theta equals pi minus 0.322, which is 2.82, or 2 pi minus 0.322, which is 5.96. That's are the two solutions. Okay, and that's the end of chapter 7.6. Next lesson, we are diving deep into modeling. Okay.